Hello, everyone. Welcome to Accolite Digital Connect, our thought leadership series on the latest in domain and tech. I'm Srikanth, your host and the head marketing for Accolite Digital. Today's session is from the cybersecurity space, and the topic is DevSecOps. And what we're going to talk about, it's about preempting software supply chain attacks in the through DevSecOps. Today's call, we have two eminent speakers from the cybersecurity space from Accolite Digital. The first is Dharaninath Doppalapudi, fondly called as DD, and he heads the cybersecurity practice. Our second speaker is Dhruv Gupta, and he's the CISO in Accolite Digital. Now I'd like to pass it on to DD to take this forward.
Thank you, Srikanth. Hello, good morning, and good afternoon, good evening, depends on where you are. This is Dharaninath Doppalapudi from Accolite Digital, an emerging digital and cybersecurity services company based out of Dallas, Texas. DevSecOps solves the problems around risk, security consciousness, velocity, and software quality. Let's see why and how. In the past, the role of security was isolated to a specific team in the final stage of development. That was not as problematic when development cycles lasted months or even years. Effective DevOps came up, and it ensures rapidly and frequent development cycles. But outdated security practices can undo even the most efficient DevOps initiatives. DevSecOps means thinking about application and infrastructure security from the start. It also means automating some security gates to keep DevOps workflow from slowing down. Selecting the right tools to continuously integrate security in the CI/CD pipeline can help meeting these goals. As you can see, the CI/CD pipeline, there are multiple phases of it, and we can implement every part of the way. CI/CD pipelines is a socio-technical system composed of software tools and processes. DevSecOps unites developers, operation teams, and security professionals together. It involves and impact automating security control repositories, container registries, the CI/CD pipeline, API management, release automation, operational management, and monitoring. DevSecOps security is built for containers and microservices. The greater scale and more dynamic infrastructure enabled by containers have changed the way many organizations do business nowadays. Because of this, DevOps security practices must adapt to new landscape and align with container-specific security guidelines. DevOps security is automated, maintain short and frequent development cycles, integrate security measures with minimal disruption to operations, and keep up innovative technologies like containers and microservices. Next slide, please. As you can see in the CI/CD pipeline, the security protocols can be applied at each stage of the cycle. Starting from the planning stage, team needs to adopt application criticality profiling, migration assessment, security coding testing. Similarly, in the design and build and test release phases. And let's take the build stage, the test open source code. We can adopt software composition analysis, SCA, and there are plenty of tools to name few: Black Duck, Sonatype, Nexus, etc. To test the proprietary code, we use SAST, which is Static Application Security Testing Tools. However, SAST cannot detect runtime vulnerabilities or issues to environment in which application runs, and so does we adopt DAST, Dynamic Application Security Testing Tools, to examine the app when it runs and to find flaws and weaknesses. Few tools to name here for DAST and SAST are Fortify, Web Inspect, Veracode, IBM AppScan, and Checkmarks, and etc. etc. Now, effective DevOps security requires more than these tools. It builds a cultural changes of DevOps to integrate work of security teams sooner than later. DevSecOps is all about built-in security, not security that functions as a perimeter around applications and data. You may have heard the saying, security is not one person's responsibility, it is everyone's responsibility in the organization. DevSecOps involves everyone in the process and practices of ensuring security. Developers, app managers, application teams, security teams, reviewers, testers, everyone has got very important role to play ensuring the security for the organization. However, DevOps programs are very ambitious and challenging to carry out. Organizations have to change their resources, tools, cultural and structural changes. Next slide, please. Next slide, please. Okay, thank you. DevSecOps means that the security is a shared responsibility and everyone involved, as I said, in the SDLC process that have the role to play in building the security into DevOps CI/CD pipeline, as you see. It enables business to rapidly bring new applications to market, but in a safe and compliant manner. Shift left is an approach to software testing in which tests and fixes are performed earlier in the development pipeline. More to the left when looking the life cycle diagram that flows from left to right. It enforces the agile principle, test early and often, by building the testing into all stages of SDLC. When you shift the testing requirements left, the support burden is reduced. The business derives direct, tangible value. Customer experience is better. In fact, Amazon pushes code thousands a time a day with no uptime to deliver consistently great customer experience. Next slide. Okay, Dhruv, want to take?
Yeah, sure. Thank you. Hi, this is Dhruv Gupta. I'm based out of Mumbai, India, and I'm looking at the cybersecurity practice along with Didi at Accolite Digital. And also I'm the Chief Information Security Officer at Accolite. So I think we've all been talking about the shift left approach. So I think this diagram specifically will give you an idea that you don't need to be married to any specific tool, but we need to look at security at every stage of the DevOps pipeline. So if you go towards left, right, when we've been talking about shift left, so I mean, putting in security at the initial design stage, putting in tools like JFrog, Snyk, Skim at the IDE plugin stage, putting in pre-commit hooks, managing secrets using things like HashiCorp, doing static application security test through tools like Checkmarks or Fortify or Web Inspect or stuff like that. Even checking in for your software composition analysis, which is nothing but checking security loopholes in some of the open source components that you're using, or while deploying the code, if you're also doing dynamic application security testing by using tools like Rapid7 or Acunetix, or checking infrastructure as a code, checking modules of the code, checking in interfaces, doing runtime application security tests, or even integrating it with your web application firewalls like Imperva, like Cloudflare, like putting into your SIM tools like Splunk, or doing some sort of chaos engineering. I think it's a 360-degree approach of not just technology, but a security-driven culture, automation, and management support. So I think this is just more of a elaboration as to, if you have to achieve a DevSecOps driven culture and a secure code by design, you need to involve the right set of technology with the right set mindset to be able to deliver secure code. So yeah, we can move on to the next slide. I mean, again, we are all aware, right, that while developing code, while following DevSecOps or while following DevOps, for example, so there are multiple stages, whether it is planning, there is development, there is product release, there is acquisition, there is maintenance, there is disposal. And trust you me when I say this, that you can actually get any type of attack at any stage of the development pipeline. And that's why we call it the software supply chain attacks. I mean, things like your dependency confusion, where is nothing but just you put in an insert in a malicious package, which is installed in your initial design phase, and it keeps running in and starts giving you what you say jailbreak access to your iPhone. I mean, it is possible in a whisker. Or simply putting in some sort of SQL injection by just removing a couple of your apostrophes from your code and just getting you full access to the database. I mean, multiple things are possible. And I mean, from a planning or a simple design stage, what you say, malicious code installation, to even putting in some of the other, what you say, ransomware or some sort of malicious code in your product release, or by obviously causing some sort of data spillage while the software is getting disposed of by not properly cleaning it or wiping it. I mean, there are all sorts of attacks which are possible at every stage of the DevOps pipeline. And it is important that we take each and every stage with equal seriousness, equal sincerity, and we are able to look at all the attacks more preemptively. I mean, a couple of attacks I'll be explaining in the coming slides, but just to give you an idea that some of these larger attacks like the SolarWinds or the Kaseya ransomware attack, all of these were nothing but malicious packages installed and sitting dormant for around 3 to 4 weeks, which led to a much larger, what you say, exploitation of the MITRE attack framework, or the kill chain, wherein once you are inside, then you can do anything, right? So we can move on to the next slide, I think, for better details, I guess. So, I mean, just to give you an example, we are all aware, we've all heard about the SolarWinds, but we just, I mean, I'm just trying to see if we can understand it in more, in a simpler way, as to where was the mistake, or where was the loophole which made all of this happen, and what we can learn from it. So, I mean, if you just look at it, we've been talking about the CI/CD pipeline, right? So the Orion software, which is again the software which was delivered by SolarWinds. I mean, it had a simple Trojan which was deployed during the development stage, and it went inside the SolarWinds software, and it was lying dormant for 14 days. And when the SolarWinds application protocol was communicating with the command and control server after that 14-day period, it was able to do every sort of reconnaissance and privilege escalation because of the fact that that protocol was easily acceptable. So what the learning from that is very simple, that the attacker won't come today and say that, won't come and say, it's like a typical scenario of a live attack or a human attack, when somebody won't come and tell you that that person is going to be a mischief to you, but they may create your trust, gain your trust, and then after 3 or 4 weeks of lying dormant, they can just completely go hula. And then obviously once all of that happened, then you can see that the access fortification happened, MFA was bypassed, and obviously once the target was reached, then there were so many systems, right? We talked about FireEye, which is again a security vendor only, but just giving you an example that they were also one of the SolarWinds customer. And I think, to name a few of them, I guess, I think the list is endless, but I think all the large banks and everyone was using this SolarWinds network management software. So yeah, so simple, I think simple security, simple DevSecOps procedures, simple security driven cultures, could have saved us from such a large, breach. We can move on to the next one. Even if I just talk about this Kaseya, while Kaseya was never, it got celeb status obviously after this attack, but nobody was aware of Kaseya. But just for everyone's benefit, Kaseya is nothing but a remote monitoring tool which is used by some of the largest banks and the retail companies, and it is nothing but a tool wherein it contains a lot of credit card information, PII, SPI of the customers of some of those largest companies that I've just mentioned. For the sake of privacy, I won't name a few of them, but just to let you know that any name that you could think of is a Kaseya customer. Simple Revil ransomware installation in the VSA platform, which is nothing but a SaaS-based platform, led to all the managed services providers of Kaseya getting compromised. 1 million. The official website of Kaseya says that the official Revil ransomware website, says that 1 million customer data got compromised, although the Kaseya website talks about 15,000. But assuming if it is even lying somewhere in the middle, the number is humongous. Nothing but a simple code level, flaw, or a simple cultural flaw, again, pertaining to not involving security from the start and not getting your codes vetted or not getting your designs. Just leaving security to the end, which is in any case costly as well as much more insecure. So yeah, we can move on to the next slide. There are plethora of precautions customers and vendors can take to protect any type of attack. Obviously, this doesn't guarantee that there is 100% attack level protection that we are talking about here, but small things, right? That a customer, while using any vendor codes, they can have a regular connect with the vendor and just check whether they are using secure codes. Are the vendors themselves SOC 1, SOC 2 certified or ISO certified? Are they maintaining software inventory? Do they have a standard cybersecurity framework they're following? Are they following a NIST or again the SSA 16 or the ISO? It doesn't matter as long as there are some protocols being followed. If it's a credit card company, you can even talk about a PCI DSS. Is there a supply chain risk management that is implemented? Is security a part of the culture? And same thing for the vendors, right? They need to also check for all their open source components. They need to check for their third-party libraries. They need to do a regular VAPT. They need to use all the cutthroat industry technology, whether it is SIEM, EDR, IDAM. They, again, following frameworks, following audits, getting that regular connect. It's a 360-degree approach wherein using the best quality tools to secure your code, using the right set of tools to protect your attack surfaces, which includes your endpoints, mobile phones, laptops, databases, including your physical perimeter in the best possible manner, creating a security awareness culture, automating the security process, and making security a priority. I guess it's a 360-degree approach, and obviously DevSecOps plays a major role here because of the fact that 90% of the breaches are happening through installation of malicious code by either somebody just trying to create dormant processes or changing some sort of registry keys within the laptops or the systems by just getting an entry which is not desired, right? So so many things we can do, I guess. So we can move on to the next one for the time.
Okay.
Over to you.
Yeah. Thank you, Dhruv. In summary, DevSecOps solves both DevOps and security compliance at the same time by adopting the DevSecOps. It is not a seamless and a financial benefit, and also across the organization, we can resolve many problems which comes out later. And DevOps programs are ambitious and challenging to carry out. And we at Accolite Digital, we have adopted and we are helping our customers in adopting the DevSecOps functionalities and implementing the tools for them. And organizations should invest in DevSecOps to prevent attacks in their supply chain, and they must judiciously manage their resources, tools, cultural and structural changes. That's all. That's all from me, Srikanth.
Yeah, thank you very much, Didi and Dhruv, for this very insightful session on DevSecOps. I'd also like to thank our attendees. If you have any further questions, please do drop in a comment, or you can reach us at Didi's email ID, which is dharaninath@accolitedigital.com. Thank you very much, and look forward to your attendance in the next Accolite Digital Connect session.